Right, GM everyone, we are back for day 12, and yesterday we wrote this bunch of code which was for a faucet and which was for testing this. Now what I have planned today is writing the liquidity pool and testing it. So let's just init the file here. I'll explain it in a bit what we are going to do today. So my idea of doing this is uh, having this pool, and whenever someone, and this pool has an native token called LP token, which is minted and burnt. Okay. Now, instead of just transferring and then receiving or claiming back, why am I minting and burning this? Because this LP token represents the share of your liquidity provided. Cool. So at any given time, anyone can come and take their liquidity back, and they will give the LP token, and as per their LP token, the share of amount A and amount B will be given to them. So LP token will have a fixed supply, will have a fixed supply, percentage of that will be given. Okay, cool. So I think that makes sense, a lot of sense. Now let's take a moment where I set up the skeleton of the project and we'll get back. Okay, so the skeleton for this contract will have the following functions. Let me just write the initial things here. What are we using in other? We are using 20, so let's keep it at 20, and let's import the ERC20 and ERC20. And should we get an ownable? I don't think we should get an ownable here. Let's just add this here, and let's think now of what we can do here. So the functions that I want here is liquidity pool. Okay, this is one thing, and LP token is ERC20. Okay, cool, that's fine enough, to be honest. And the LP token will not be sent to the pool initially, but it will have a pool address, right? So all of them will be given to mint and given to whoever is deploying this token. So let's write the constructor, and here's the 20 constructor, LP token, and let's keep it LPT. Okay, and let's give it an address pool. Okay, address public pool, and this will be pool is equal to message.sender. Okay, this is the right constructor here. Oh, what's the problem here? Sorry, that's the comma missing in the previous line. Now there will be a mint function here, function mint. If the message.sender is not the pool, then only pool can mint these tokens basically. So this will be an external function, and the argument that it will take is UM256 amount. Okay, if message.sender is not pool, then mint pool and pool amount, and we don't need to mint this to pool, we need to mint this to an address too. Okay, and let's give it this, and let's give it 2. Okay, since that is fine, let's make a function called burn, and burn can only be done by someone who is pool, so that also has this error called not pool. We don't need to transfer these, so let's keep it there. And now let's init this in the main liquidity pool, right? So the main liquidity pool will have functions like add liquidity, like second, what am I missing here? Yeah, Why is it not doing that? External and this guy function remove liquidity, swap A for B. Okay, and similarly swap B for A. These are the four primary functions. Now there are some helper functions here that we'll use. First, let's write the getter functions. So get reserves, and the get reserves will return us the reserve of A and B. Now the first helper function that we'll write is called square root, basically for square rooting through these. So u into 56x and internal pure return u into 56y, and this will be very simple. We'll write some assembly code. I took this from AI, but I think I have better code written somewhere. Let's take that. If y is greater than this, and yeah, these are some functions that you can directly init from libraries, but I'm building this here. Okay, let's take a pause here. Okay, so let's just make this function where we have x. Wait, let's just write this like that. Okay, let's just think of what we'll write here. If x is equal to 0, return 0. If z is equal to x plus 1 by 2, while z less than y. Yeah, I think this is the right for a square root here. I actually have a square root function written, so I can just copy it here. This says if size, then we use this. If not equal to 0, else z is equal to 1. Yeah, this makes sense. And let's get a minimum function u into 56x comma u into 56y, and it also returns a u into 56, which will be x or y, and we use this when we are transferring the liquidity tokens and stuff. So now the primary thing that we need to define is this pool will have IRC20, public token A, public token B, LP token called LP token. Then it will have a reserve A and a reserve B. And also then we'll have the errors here. So error insufficient liquidity. What bad spelling here. Insufficient liquidity. And on the other hand, we'll have error called amount cannot be 0. These are the two errors that I can not be 0. That is what I can think of for now. And now the constructor will need a token A address and a token B address, right? And also we need to deploy this token inside of this contract. This is not a very good practice, but let's keep it like that for now. Constructor. So this guy has LP tokens here. And now the first function that we'll write is add liquidity. Okay, add liquidity will have u int amount to 56 of A and amount B. So let's give those two, amount A comma u into 56, amount B. I'm not sure if we need to keep them same, but for now let's say amount cannot be 0. So if amount A is equal to 0, amount cannot be 0. Now the total supply will be let's think of this for a second. Okay, let's see the diagram of the pool that we were trying to create, and here we'll provide LP tokens based off on what amount of liquidity have they provided, right? So we'll just transfer those tokens, and then we'll init how much liquidity do we want to give them. Okay, so token A dot transfer. Okay, reserves are added here. Now if let's say if LP token dot total supply is equal to 0, okay, then let's just say u into 56 liquidity. Okay, now here the liquidity will be square root of amount A into amount B. Okay, because for initially when tokens are 0, we don't know how much tokens do we need to provide them, right? So let's say they are providing us 10 into 10, that is 100 tokens, 10A and 10B. So we need to give them 10 of those. Okay, that's what I am considering from first principle logic. There can be better logic here, but let's keep it like that for now. Okay, and now the liquidity will be equal to minimum of both. Okay, so minimum of, so let's see here. So the total supply of LP token, imagine it is LP token is 10,000. Now amount A into LP token divided by the total reserves. Okay, so the amount of A that is providing, let's say 10 into total supply of LP token, that is 10,000, and divided by how much is A in the reserve, so let's say 10,000. So then we'll provide them 10 LP tokens. Okay, if this is 1,000, then we provide them 100 LP tokens. Basically means that whenever you are providing liquidity early, you'll get more tokens. Okay, so liquidity is equal to minimum of, yeah, this. Okay, minimum of whatever. If this is minimum, then this, and if this is minimum, then this. Okay, that makes a lot of sense. Now remove liquidity. We don't want to provide them how much do they want to claim. We'll provide them how much tokens do they have. So how much liquidity they want to exit here. Shit. Liquidity. Sorry, I'm misspelling a lot of things today. Now here, let's say if liquidity, we'll revert that it is insufficient amount of liquidity to be claimed back here. Let's take a pause. I'm getting a call. So we are back here. Now, this is the logic that I've thought of for providing the LP tokens. Now we need to think of a logic for removing the liquidity. Okay. So token A, so UN256, how much amount of A that we need to provide him will be given with the formula of this X into YK, right? So amount A is equal to how much liquidity does he want to remove? Liquidity, yeah, I'm very misspelling today. Liquidity into reserve of A divided by whatever supply of tokens is present. Okay, cool. Similarly for this, and we go there and we reduce those amounts, and then we burn those tokens for the message.sender, and then we transfer those tokens. So there are three processes when they are removing liquidity. So to remove liquidity, let's keep those small. Remove liquidity, we first need to check for amount A and amount B against their liquidity, then burn LP tokens, and third is reduce the reserves, and then transfer the A and B. Okay, that's made for the LPs. Now, do we need to include fees here somewhere? I think we should keep a normal fee here of swapping. Okay, let's add a fee here. Let's make everything first, and then we'll add the fee protocol here. Okay, that makes more sense than directly trying to introduce a fee here for LPs, because I want that if they're putting, let's say, 100A, then 3 of them are going to fees. Okay, I want that, like, just 3% fees. I don't see it as a bad. Insufficient, I'm not sure what's the spelling of insufficient. Insufficient, this is the spelling as far as I know. Yeah, misspelled this, right? Insufficient, CIENT. Damn, man, damn. Okay, insufficient liquidity. Okay, and let's just copy this and let's just paste it here. Yeah. spelling mistakes are bad. I hope this went over. Okay. Now swap A for B. So U into 56, amount A. Let's say if amount cannot be 0, that's what we need here. Now unit amount B will be amount A into reserve B divided by reserve A. That's the simple math that we are talking to since let's say last year, last video, sorry, I'm saying last year, yeah. So that's the logic that I see here, and then we increase A and increase B, and token dot transfer. I don't see any problems here. Similarly, let's write this function to U into 56 amount B, and same logic here, but what else can we do? Okay, what else can we do here? I think we should have a simulate swap function here, so which would need a get amount out. So I think we need a lot of helper functions, so let me write those functions and we'll get back. Okay, so I think I have done everything here. So I have introduced a fee here. So a fee here, private constant fee, that is 0.03% fee, which says that for every 1,000 we get 0.3 out of it, whatever. And then there is add liquidity, which is also with a fee. And then there is remove liquidity, which is also with a fee. And swap A and B also includes the fee module. Get reserves. Now there is a simulate swap function which is used where things like let's say uniswap, app.uniswap. So wherever we go and see that we want to swap, okay, explore, let's say we want to swap here, right? So this estimation that we get initially, let's say ETH, and we want to get USDC, okay, 1 ETH. This the code that goes, it gives you a simulated swap. So current prices are simulated here, and then you're returned what amount you might find again. Okay, so we have also built those simulate functions here. Then there is square root and stuff. Okay, now I think we should write tests for this. Okay, yeah, I think we should. So we can add things here only where we have the setup function. So we can go for faucet and then providing liquidity also here only. Let's do that. Okay, import liquidity pool. Okay, and here what we are going to do is when it is LP provider. So what does he do here? We created a function called faucet creation, right? Yeah, we need to put its logic here. So let's go for liquidity pool, and faucet creation, this function. So let's cut this out. Oh, no, faucet creation, yeah, this guy. So, and let's keep it here. The thing that are done here is what I want to go for here. Okay, faucet address, token address A, and token address B would be here. Okay, now here let's say this is done, and now liquidity pool is equal to new liquidity pool. Okay, now let's divide by 2 as half of them are gone there. Not transfer, actually, not transfer, not transfer. We need to liquidity pool dot add liquidity, and these will be, yeah, I think that's it. Yeah. We'll fix this, right? We'll fix this here. This guy. Let's open ChatGPT here and try to write some tests here. So let's close the sidebar. Let's open the ChatGPT. Where is the liquidity pool? And where we'll write the test, we will write the test here. I'm not sure this big of a prompt will go in. Not sure. Actually, you know what? Let's write these again. Let's write the setup again. Let's write everything. Okay. So function setup. The first function is set up. Okay. External. And the first thing that we're going to call here is liquidity pool and faucet. Oh yeah, sorry guys, that's that. And now we write the token A, VM, not prank, LP provider, token A, token B, faucet, liquidity pool, and liquidity pool is done. Okay, then we'll write a separate test where we get those in that, right? No, we don't do that. Yeah, we just token A dot transfer to faucet address faucet. And how much do we transfer? Token A dot max supply divided by 2. So like let's say half of those, right? Yeah, and similarly token B dot transfer and VM dot stop. Okay, now function test add liquidity. Okay, that's what we're going to do here. Okay, so the first thing is we do is VM dot start prank LP provider. I'm not sure if we can do this. Yeah, I think this would work. This would work. And let's see if this works. Okay, I'm not sure. Purge test. Oh, sorry, I'm on the outside of this, right? Let's see. Oh, see, yeah, we are in the contracts folder. Yeah, it ran. Okay, so we are able to provide liquidity, but are we getting those LP tokens, right? So let's go here. This is a little check that we want to do. Mines, so check if liquid are minted. LP token, yeah, I mean we can import the LP token here also. Let's do that. Import LP token, yeah, and let's keep it LP token, public LP token. Let's see. I want to write the console.log LP token total supply. I want to see this go through. Yeah, I mean LP token. Sorry, guys. What did I do? Right. I think this is done, right? I want to see the logs. If we get a total supply here, what's the problem here? Adding liquidity, approval, transferring here. The testing's failing here, and let's see why it is failing. And this is failing. Let's go to AI and see what we are missing out here. Oh. Liquidity is added. It is being sent to message.sender. Oh, okay, understood. To go and deploy this missing address this. So let's go back to liquidity pool, and here we need to see this. And let's go back and let's see what's the problem here. And the main problem that I can see for now is that we are mint function liquidity is added. It tries to mint tokens but does not correctly handle the message sender address. To resolve this, you can update the LP token constructor to set the pool as actual liquidity provider's address. The liquidity pool is created. Set the pool to message or sender. Nah, not this. Let's see. I don't think that's the problem here. So let's keep this and read this through, okay? And let's see what the error was here. The thing here that we needed to do was that LP token is not being transferred here. So we are not minting this here. So LP token instance, updating the liquidity pool here would make sense, okay? So EVM fatal error. Let's take a second and pause that here. Oh, sorry, wrong. Wrong EVM triggered. Averted. So yeah, this can work. Oh yes, we spotted the error. The error was that LP token needed a address pool here, which we provide through this address, and then we actually reference it here. So liquidity pool dot LP token. So that will give us the address here, and then we check the balance, whatever we need here. So let's test remove liquidity. Okay, liquidity, which will also be an external function. External, okay. Actually, let's see. Instead of having this as add liquidity, we can have as test liquidity flow. So we'll add and remove liquidity at the same time. Okay. So LP will have this. Okay. And let's remove some liquidity from the pool. So how much liquidity that we will remove is what we need here. Okay. So removing some liquidity from the pool, LP token. We'll send this amount here, asserting the balances. We sent all of that. Let's see if this works. I think this will fail because assertion failed. Where did it fail? Let's think of this. Okay, so LP provider, LP token amount, we send all those liquidity in, and we remove the liquidity. So this should be 0. Okay, these should be 0. This works. Okay, let's just console log this, and now we need to see that assert that LP token supply has decreased. Okay, yeah, it has also decreased. Okay, now what else was happening in the liquidity pool when we remove the liquidity? Reserves, get reserves. So console.log liquidity pool dot get reserves. This works, right? Why does it not work? I'm very bad at spellings today. And this console.log will need yeah, and this will go here. So the main thing that we are trying to do is we have to see if and token A balance of LP provider should be equal to amount of A, and this should be equal to amount of B. Let's not amount of A, not amount of B. What are the problems here? Yeah, this works. Okay, this should be equal, and they receive more amount here. Amount of A. Where is amount of A referenced? Okay, amount of A, not amount of A, not amount of A. They will need to get more than that. Okay, so I just want to see what they are getting. Okay, let's see. Okay, LP token balance, LP token supply. Okay, let's see the pool addresses before. Okay, CLG console.log pool balance before remove. Okay, let's see this. Okay, 100 million and 1 million. Okay, so now when they remove the liquidity, the amount should be transferred. Okay, so on remove liquidity, the amount is transferred. Token A dot transfer message dot sender amount A and amount B. Amount A, amount B is equal to liquidity into reserve. So this should be equal to, so assert equal token balance, token A dot balance of LP provider should not be equal to amount A. It should be equal to liquidity into reserve A divided by LP token dot total supply. Yeah, that's something that it should be equal to. See, this is where we sort of pause this video here, and this is how we test the whole liquidity pool. Let's try writing all the integrations and front end for this tomorrow. Thank you for watching, and this has been second day of writing a DEX.